Welcome back. So before the break, I took a lot of time to motivate namespaces. I did that also because it's a bit complex. So don't be scared. I'll try to explain it as simple as possible, right? So I hope I made the point that namespaces are just like family names to make sure that people with the same first name can still be distinguished. All right, now, what if we went ahead and start replacing all over the place every single name that we find in the documents, the element names, the attribute names, and everywhere we just add our family name, the namespace. So here, this is a MathML document. These are actual elements that exist. They are part of the MathML standard. And I put the namespace absolutely everywhere. Who finds this beautiful? Right, that's very verbose, isn't it? Well, computer scientists are lazy, and having to repeat the whole thing all over the place is just not an option for us. So what we do is we take shortcuts, and instead we abbreviate it with some what we call a prefix. Let's call it M for MathML. And we just use this colon character to separate. So we have the prefix followed by the colon, followed by the actual name. What is this prefix? It's only a shortcut, nothing else. It's only a shortcut that stands for the namespace. And how do I know that that prefix M stands for the namespace MathML? Because I declare it somewhere. And I declare it right there, that I'm saying M is a shortcut for that namespace, only for the purpose of this document right there. So whatever I want to put in this MathML namespace, so in this, all the objects I want to put in this Swedish box, I can just put the prefix in there, and that puts all of them in the MathML box, right? All of these elements are in the MathML box. Now you're going to tell me, okay, that's an attribute, right? This thing that I put there, that's the name of an attribute and a value. Yes, but you might have noticed something. With what letters does it start? XML. What did I tell you a while ago? I told you, you cannot start with XML because it's reserved. Well, now you know why. It's reserved because what starts with XML is special, and it's only used in order to associate namespaces with prefixes. That's why you cannot define names that start with XML because they are reserved for that. All right, so XML NS is for namespace, right? XML NS, XML namespace. Okay, so now I'm going to repeat what I've just said, but in more details to make absolutely clear. When I have this XML blah blah thing, XML NS, I'm saying that this is not a real attribute like the others. It's a special one that binds a namespace with a prefix. What it says is what is after the colon. So M is a prefix that I bind with the MathML namespace. So wherever you see M as a prefix to an element or attribute name, it means that that belongs to the MathML namespace. All right, these are called, that's the fancy name, it's called in-scope namespace bindings. That's just the bindings from the prefixes to the namespaces. Right, so now I'm giving you more terminology. M is called the prefix. Math on the right of the column is called the local name, right? It's like the first name of a person. And I'm binding the prefix M to the namespace MathML, meaning that this M math element name automatically gets the namespace associated with it, right? So M math here on the left has the prefix M, the local name math, and indirectly via the binding, the namespace MathML. This together has a name, it's called a Q name. Q name is for qualified name because it's qualified with a namespace. So math is qualified with the MathML namespace, right? Now, what happens if I use the different prefix? Well, I don't care. The prefix is totally irrelevant. I could call it foo, I could call it bar, I could call it whatever I want. It's only the namespace and the local name that really matter. The prefix is only for ease of writing, that we don't want to repeat the namespace all over the place. So if I give you these two Q names, they have the same local name, they have the same namespace, only the prefix is different, so they are equal. They are the one and same Q name, right? Only the namespace and the local name matter. Okay, so that means that I could do this. I could just replace foo, replace M with foo. This is exactly the same document, exactly the same document. I couldn't even put bar, it's still the same document, right? So here I'm giving you equivalent elements. This is everything is the same, right? So here I have anything as a prefix, so foo math, blah, blah, blah. That's the same as m math, blah, blah, blah. Notice that I do bind every time the same one, right? M and M. Here, what did I put? It's MA, that's still the same. Here you have mathematics, right? I can do long prefixes too, right? So this is also the same. So this is all the same. And oh, this is new. What happens here? I don't have any prefix at all, and I don't have anything here either. This is called the default namespace. So I can say, if I'm even lazier than lazy, and I don't even want to bother with adding a prefix everywhere, I can do even simpler than that by saying that wherever there is no prefix at all, please assume that it's the MathML namespace. And this I can do with an XMLNS declaration with no nothing, absolutely nothing. This tells me all of the elements that don't have a prefix are in the MathML namespace. That's called the default namespace. So it means that if I'm super lazy and I don't even want to add my prefix everywhere, no problem, I just don't. And I just say with this XMLNS blah, 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 it's magically saying, okay, everything in there below is in the MathML namespace, right? So that's as lazy as it gets, right? Okay. Okay. What's important to understand is that this is not the same. This document doesn't declare a default namespace. In this document, the elements are in no namespace at all. They don't have any family name, right? In this one, they do have a namespace. Every single one of these elements, the 10 plus elements there, are in the MathML namespace. Here, they are in no namespace at all. So it's important. What I'm saying here is that if you see an XML document that doesn't even use XMLNS anywhere, it's still okay. You just don't even have namespaces, right? However, in a professional environment, if you work for a company and you define XML documents, for example, you're the tax office and so on, then it's a very bad idea to not use namespaces. If you are in a production environment, you really, really should use namespaces to keep things tidy, right? No namespace, it's just for playing around. You want to quickly work with XML and learn it, then that's fine. But professional environments, you have to put things in namespaces with the domain of your employer. Okay. Now, namespaces can quickly become a big mess. How do we make sure that things are tidy? Well, there is a convention that everybody should stick to. It's that all of these XMLNS declarations, they should all be together at the top level of the document, all of them. If you want to be even tidier, you can even sort them alphabetically. I mean, I like to sort them alphabetically because it looks even nicer. I did here, bar comes before foo, but that's pretty much it. So in a tidy document, you put all of your namespace declarations at the top, and then you use the prefixes. So here I have two namespaces, right? I'm mixing two namespaces, bar and foo. And you see that some of my elements are prefixed with foo and some of them are prefixed with bar, but my declarations, my bindings are at the top, right? And if you want to also be nice to other people, you should try to stick to the same prefix. Because I told you the prefix is irrelevant. So you could say, okay, I can just put whatever prefix I want, right? You're going to drive people crazy. If you want to really make sure that the people who use your documents, they are not too confused, then you should try to use the prefixes consistently. It's a very good idea, right? It's not that it would be technically different, but you're basically just making other people's life easy when they look at your documents. All right, okay. All right. The default namespace, this is also a recommendation, only use the default namespace like this if it's the only namespace in the documents. Do not mix the default namespace with other namespaces. You're going to make people's life a nightmare, right? Some people do it. It makes it very difficult to read. So either you have your namespaces like this with prefixes, or you have a single namespace that is the default namespace. Don't mix them. And again, here I'm repeating what I already said. It's not the same document. On the left, all the elements are in the default namespace, example.com/foo. On the right, they are in no namespace. Right? So you end up with 4 different designs that are recommended. First design on the top left, no namespaces at all, but only for development purposes, not in a production environment. Then you could have on the top right a default namespace in the entire document. Below, for many prefix namespaces, here I have A, B, C, D, alphabetically sorted, all tidy. And 3 is just a special case where you have only 1, right? You might as well have made it the default namespace, but you don't have to, right? So 3 is just a special case of 4 where you have a single namespace. That's it. Stick to these 4, nothing else. For whom is that clear? All right. In practice, you will see that this is a huge mess. You should never do that. But yeah, that's basically how things are. But for the purpose of this course, we don't care about this, right? This is just a huge mess that you should not do. Okay. And now I'm pushing it for those of you who are interested in more advanced things. If you have a default namespace that only applies to the elements, meaning that the attributes that don't have a prefix, they are never in a namespace. So at here is not in the default namespace, right? Only the elements are. And here, do you see what's wrong? I have foobar with 2 attributes, foo at and bar at, right? But these attributes, do you see that they are the same? Why are they the same, these 2 attribute names, foo at and bar at? Why is this disallowed? So they have the same local name, at. They have different prefixes, but look what the prefixes are bound with. It's the same namespace twice. You're binding the 2 prefixes to the same namespace. So basically, these 2 attributes, they are actually the same. But I told you, you cannot have twice the same attribute name, right? For whom is that clear? All right. Remember that the prefix doesn't matter. Only the namespace does. So these 2 attributes have the same namespace, example.com/foo, and the same name at. Note that if you don't bind the 2 prefixes to the same namespace, you don't run into these problems, right? So you are going to save yourself these issues if you make sure that you always have distinct namespaces and distinct prefixes. Then you don't need to worry about it, right? So it's more for the curious, like a corner case. Okay. This is something that I like to give as an exercise. So try to take that document and find all the mistakes, right? I'm going to, do you want to catch some of them? Then I'll give you the other ones as homework. Who sees mistakes in there? Let's ask for just 2. Give me 2. This is not a well-formed XML document. 2 reasons. I see it on Zoom.
Title is double. A type movie.
Movie. Yes. What's with movie?
It just said movie and movie.
Yes. So the lowercase, uppercase, right? I think this is what you mean. That you have here movie with a lowercase, small m. But here you're closing with an uppercase. This is indeed a mistake. This you cannot do. It's case sensitive, right? So this is a mistake that makes it non-well-formed. Anything else? So that's the correct answer. Anything else? Do you see other mistakes? Can you see, for example, a duplicate attribute here? Do you see it? There is a duplicate attribute. On Zoom, do you see that there is twice the same attributes? Nobody? Look here. Comment, text, text. This is also disarrowed. This is another example of what is wrong here. So there are many others. I will leave them to you as homework. I think I have the solution on the next slide, so I'm going to try to quickly pass. There you go. So just try, look at it offline and try to figure them out, and then you can check. Now, an even better way to check that automates things is to use an XML editor. There is one that is quite good actually for teaching purposes, which is called Oxygen. And ETH was so kind as to acquire a license for all of ETH. So everybody you can go to the ETH IT shop and you can download the Oxygen editor for free as a student, right? So I strongly recommend you do it today or for the exercises, download this, because then you can open files. It will point to all the mistakes. It will pretty print the documents for you. Then you can use it also with schema validation in 2 weeks. So it does all of that. And this actually can be quite useful if you have student projects or theses later that use XML or JSON, because it also supports JSON. Then you can open your documents and edit your documents with it, right? So we'll use it in the exercises. And I recommend that you already go ahead and take it from the ETH IT shop. Okay. It will do this basically. If you put a document, it will nicely put colors, syntax highlighting to make it look good. And then you immediately see the tags, the text, the attributes in orange. You see the comments in green, and so on and so on and so on. Okay. Okay. Let me wrap up then this part on syntax. So after I scared you with XML, but don't worry. In the rest of the course, the focus will be a lot on JSON. Right, it's easier, and a lot of things of JSON anyway also apply to XML. But it's good that you've seen XML because it's there in the real world. Many companies use it, so you'll see a lot of data in that format. All right, so I already showed you how you can express a relational table in JSON. Now here is how you express it in XML. Right, so in the case of the first tuple there, the first row of the relational table, you could express it in that way using elements for every column. Right, so you can product is phone, price is 800, customer is John, quantity is 1, right? And you put it inside a parent element that you call sale. That's typically the singular form of the table, and there you go. For whom is that clear? Right? It's a very specific use of XML that's flat. It's completely flat. We just have text inside elements, plain and simple, and that's pretty much one row of a relational table. Now you could have all the rows. How do we do it in XML? You see, it's a bit different than in JSON. In XML, we typically use the plural form and the singular form. The plural form would be sales. So we have an element sales, and then we use the singular form sale for every one of the rows in there. So we have one sale that is a phone, another one that is a phone for Peter. Then we have a phone for Mary. Then we have a laptop for John, and so on. Every child element here corresponds to one row here, and then the elements here correspond to the columns. That would be the most natural way to map a relational table to an XML document. Who finds it natural? Okay. Now, this would be another, no, this is actually the same example, but pretty printed. Here I didn't pretty print. I just put one object on one element on every line. Here it's pretty printed. So if you go to Oxygen and press some keyboard shortcut or go in the menu and ask it to do it, then it will nicely put one element per line like this and tabulate and present it nicely, like you see on the right. And then you see this is the same data that you have on the right as the table. Note that this is a very specific case where this XML document has patterns, it is structured, it repeats all the same, always the same elements and so on. So it's a very particular case. Just like JSON, an XML document can also be a mess, right? You don't have anything that enforces it, but in many cases, there is a bit of structure like this in an XML document. Now, what about nestedness in JSON? Yes, go ahead. So the question I'm repeating for the people on Zoom, how do you define the type, for example, varchar 30, numeric, and so on? This is done separately in what is called a schema, XML schema. So in a schema, we'll see that in 2 weeks. What you can say in XML schema is that the element that is called product must be a string. The element that is called price must be an integer, and so on. So you define it separately in an XML schema. And then you can do it in Oxygen. You have the schema, you have the document, and you ask Oxygen, is that document valid against my schema? If it's an integer, it's going to say, yes, it's valid. But if you expect an integer and you have a string here, it's going to say, no, it's not valid, right? This is called validation. What's interesting is that in the case of XML and JSON, the validation happens later. You first have your document, and then you validate. It's the opposite of relational databases. In a relational database, you first put your schema in there and then populate the data, right? So this is something that is particular to big data and to semi-structured data, is that the validation of the data types is decoupled from the actual documents, and you can do it later. Okay, did I answer your question? Okay, awesome. So this is for this table. And now we can nest things. So what does it look like? In JSON, it was an array of objects, right? So what do we do here? Well, this is just one row, but I have a nested table in here. So my row corresponds to that sale in the singular. Then I have product and price. You see product is phone, price is 800, but looks like what's happened here, orders. I have again a plural form, then a singular for the row. And now I go row by row, order customer John quantity 1, customer Peter quantity 2, customer Mary quantity 1. Then I close my orders. So you see orders goes from here to here, and that's my nested table from here to here. And then I close my sale, and then I continue with the other rows, right? So this is how you nest in XML. Yes, you have a question? Oh, is it the pop-up or? I see my pop-up.
In this document, is the schema the sales, like the doc type, or?
Oh, so this here is a different document. So this is the flat one corresponding to a flat table. That would be the nested version, right? The doc type always must match the top level elements. Was it your question, or did you have another question?
What I mean is, like, when you have the Oxygen software, you have the schema that's a separate.
Yes.
The separate.
It is a separate document.
Separate file, and do you declare the schema outside of the XML file?
You can. So basically, the question is, I'm already basically telling things that we'll do in 2 weeks, right? But I can gladly already explain now. So there are many ways that you can bind a document with a schema. One of the ways is external. You can tell Oxygen, here is my document, here is my schema, tell me if it's valid. There is another way, that is by adding at the beginning of the XML document, you can add some link somehow to the schema, right? Oxygen does it automatically, so you don't really need to remember how this is done. So if you actually ask Oxygen to associate a document with a schema, Oxygen will automatically add some stuff at the beginning of the document to link it with the schema, right? Was it your question? Yes, so the doc type is really a legacy thing. I put it in there just so that you see it and that you see that it's there. Technically, what used to be in the doc type is the former generation of validation. We didn't have XML schema yet, and so inside the doc type, you actually had the type declarations. But this is really something that now came out of trends. So this is something people no longer really do. Right. So this is why the doc type is more like something cosmetic. So it's just something you see here, but first you don't have to have it. And just, if you see it, then don't be surprised. Right. Okay. Any other questions? All right. So this is it, right? This is how you handle, just like JSON, you can handle the data and the nested data in XML, right? So now you see XML or JSON, it doesn't really matter. Right, the two work pretty much in the same way. So this whole thing about XML and JSON, and I told you, you can, I'm not saying that you should, please don't do that, but if you did post on an internet forum and asking people if JSON is better than XML, then you would see just immediately how people, it's just the VI versus Emacs or Windows versus macOS versus Linux, people get emotional. I don't want you to. Right. In fact, in terms of big data and the way that you use the data, it's basically irrelevant. Some people make an argument of verbosity between the two, but in fact, once it's in memory, it's processed in pretty much the same way. There is one objective difference between XML and JSON. One use case that XML actually does better. That's the publishing industry. If you want to store data that is actually scientific papers or books, you know, like HTML pages, then XML is easier because of this way you can mix text with tags that you cannot do in JSON. But for the rest, for this, XML or JSON really doesn't matter. It's really the same thing. And that's the reason why in this course, I'm going to focus a lot on JSON, actually, for what we will be doing, but having in mind that the two are actually quite good. Just so you know, there's not only XML and JSON, there's another one called YAML. That means yet another markup language. But I don't even need to really tell you about it because I'm pretty sure you will recognize what that does here, right? So you basically have the same idea of objects, the same idea of lists, you know, like arrays, cities, Zurich, Geneva, Bern would be an array. So yeah, that's YAML, and that's another example of syntax. Actually, it's growing in popularity. It's almost now taking over JSON somehow. So who knows, maybe in 5 years, I'm no longer going to teach JSON, but YAML instead, but who knows? Okay, but for the purpose of what we are doing, who cares? XML, JSON, YAML, it doesn't matter because what we look at is the data modeling, the schemas, the structure of the data, and this we will do in 2 weeks, and that will be completely orthogonal to XML, JSON, YAML, and so on. Okay, so this was the last slide of the syntax lecture. I'm going to move on to white column stores. Do we have any question, anything that is unclear? All right, so now I'm going to put this thing about denormalized data. So the idea of denormalized in the sense of nested and heterogeneous. So the XML, JSON, YAML. Let's put it in parentheses for 1.5 weeks, maybe 2 weeks. We'll now study white column stores. And in 2 weeks, I'll come back to that, but then we'll look one level of abstraction higher. We'll show that these are trees. When you look at XML or JSON or YAML, these are trees. And we'll see that when you validate these trees, you get data frames. Who heard of the word data frame? You did, right? There's pandas and so on, all of these hype. So we look into data frames in 2 weeks, and we will see that data frames are actually valid JSON or valid XML. This is what a data frame really is. Okay, but let's close that parenthesis on syntax and move over to white column stores. So I'll see you on the other side.